welcome to this explainer. Today, we're exploring what is honestly the most teasing, tantalizing point in the entire night sky. We're talking about the absolute closest star to us outside our own solar system. It's agonizingly close to our cosmic neighborhood, and yet it's separated by an unfathomable abyss. You literally can't even see it with the naked eye. For the longest time, it was just considered this incredibly dim star, while simultaneously being one of the most violent. But well, recently the whole shebang changed. We found planets there. And suddenly, conversations about traveling to another star went from pure science fiction to, actual serious projects debated by top scientists. So get ready, because we are embarking on a wild journey to our nearest stellar neighbor.
We usually mean the Alpha Centauri system. If you're down in the southern hemisphere, you can literally just look up and see this brilliantly bright point of light. It's the third brightest in the sky, actually. But that single point is really two sun-like stars, Alpha Centauri A and B, and they're locked in this 80-year orbital dance. But hiding in the dark, way out there, is the third member of the system, Proxima Centauri. It's completely invisible to us without a telescope, yet it's the absolute closest star to Earth. Right away, this is the first major paradox of our closest neighbor. So here's our roadmap for today's overview. First, we've got the triple star paradox. Then we'll look inside the red dwarf. After that, the second Earth illusion. Fourth, we'll dive into the disputed planets. And finally, sailing to the stars.
All right, section 1, the triple star paradox, our hidden neighbor.
Space really only looks cozy in those beautiful, heavily edited astronomical pictures. In reality, even our closest neighbor is separated from us by a massive, mind-boggling void. Astronomers actually knew about the bright Alpha Centauri pair all the way back in the 1500s, but it took over 200 more years to find their hidden companion. The breakthrough finally happened in 1915. A Scottish astronomer named Robert Innes, working down in South Africa, was comparing photographic plates taken years apart, and he noticed his faint little star moving slightly against the background. Crucially, it was moving right in tandem with the brilliant Alpha Centauri pair. When he ran the math, he realized this dim little dot was actually slightly closer to our sun than its big bright sisters, hence the name Proxima, which just means nearest in Latin.
But here is where the geometry gets incredibly hard to wrap your head around. Even though Proxima is part of the Alpha Centauri family, it is separated from its two bright siblings by roughly 2 trillion kilometers. 2 trillion! When we say it's part of the system, I mean it is completely out on the absolute farthest fringes.
Which naturally brings us to a huge question. Why is it even there? Was Proxima born from the exact same gas cloud as its bright neighbors? Or was it just some lone wanderer that got captured by their gravity during a chance encounter? Honestly, astronomers are still fiercely debating this. What we do know for sure is that Proxima takes about 550,000 years just to complete a single orbit around the central pair. And the math shows this triple alliance, it isn't permanent. In about 3.5 billion years, as the main binary stars age and lose mass, their gravitational grip is going to weaken, and Proxima will likely break free to just wander the galaxy entirely alone.
Let's move on to section 2, inside the red dwarf, a powerhouse of chaos.
Now, what's really interesting here is the star itself. Don't let its dimness fool you for a second. Proxima is a red dwarf, and it is an absolute powerhouse of chaos. It only has about 12% of our sun's mass and 15% of its diameter, but its material is packed so tightly that it's 40 times denser than our sun. Because it's so small, the extreme heat from the core literally boils all the way up to the surface in a completely turbulent, churning mess. This constant churning generates a terrifyingly strong magnetic field that violently snaps and bursts. Back on May 6, 2019, astronomers caught a flare that was the brightest ever recorded for this star. During these flares, Proxima blasts out just massive, deadly amounts of X-ray radiation. In fact, at any given moment, about 88% of its surface is active. Compare that to our sun, which is much, much quieter, even at its absolute peak. But here is the ultimate paradox of Proxima Centauri. Despite its violent, explosive nature, it burns through its nuclear fuel incredibly slowly. I mean, so slowly that its lifespan is estimated at 4 trillion years. Let that sink in. To put that into perspective, our sun is going to die long, long before then. Earth, our sun, our entire solar system will be completely gone, and this violent little red dwarf will still be quietly shining away in an empty universe. Absolutely wild. Up next, section 3, the second Earth illusion, habitable but hostile.
So, back in 2016, headlines around the world excitedly proclaimed the discovery of a quote-unquote second Earth orbiting the star.
Well, let's look at the reality here. The planet is called Proxima b. And yes, it is roughly Earth-sized, and yes, it sits in the star's habitable zone, which just means liquid water could exist. But actually, scratch that, habitable does not mean a cozy vacation spot. Because the star is so dim, its habitable zone is pulled extremely close. Proxima b orbits 20 times closer to its star than we do to our sun. It completes a full year in just 11 Earth days. Because it's practically hugging this violently active red dwarf, it gets absolutely bombarded with intense ultraviolet and X-ray radiation. You would need sunscreen with an unimaginable level of protection just to stand on the surface.
The challenges for life here are, frankly, immense. The brutal radiation could have entirely stripped away the planet's atmosphere over billions of years, leaving behind nothing but a barren, irradiated rock. Plus, it's highly likely to be tidally locked. That means one side always faces the star in an eternal, scorching day, while the other side faces deep space in an eternal, freezing night. However, life is stubborn, right? There might be a narrow twilight zone bordering the day and night sides where temperatures are just right. Or, if there's a deep ocean or thick atmosphere to distribute the heat, or maybe if life exists deep underground, it just might be able to survive those catastrophic stellar flares.
All right, moving into Section 4. The disputed planets, other worlds. So the crucial point here is that Proxima b isn't alone. In 2022, we officially confirmed Proxima d. This one is a tiny, scorching hot planet with a 5-day orbit where temperatures reach nearly 90 degrees Celsius. What's super amazing is how we found it, using what's called the star wobble method. The planet's gravity is incredibly faint, but it slightly tugs on the star, making it jitter just a tiny bit. Catching that tiny tremor was a massive technological triumph for us. But then we have Proxima c. Now this one is highly disputed. Initial data from 2019 suggested a planet far out on a 5.5-year orbit, but later studies think that signal might have just been errors in the data. The scientific community is literally still fiercely debating whether Proxima c actually exists at all.
Our knowledge of this system is accelerating at just a breakneck pace. Think about it. It took us centuries to finally find the Sistar in 1915. A full century later, we find the first planet. Just 6 years after that, a second one. And now, we are looking at 2036 as a proposed launch date to actually go there. Let's move to our final section and see how this all builds into an actual real-world plan. Section 5, Sailing to the Stars, a Daring Voyage. So how on earth do we cross 4 light years when standard rockets would take tens of thousands of years? We clearly need something much, much faster. Enter the audacious vision of the Breakthrough Starshot initiative, which was championed by brilliant minds like the late Stephen Hawking. Now, the plan sounds like pure sci-fi, but I promise you, the physics are totally sound. Instead of a massive, heavy ship, we launch a swarm of microprobes, and each one weighs just a few grams. We attach them to these ultra-thin light sails. And here's the trick. Light particles actually have momentum. By firing a massive laser from Earth directly onto these highly reflective sails, we can physically push them, accelerating these tiny probes to roughly 15 to 20% the speed of light. At that speed, the journey takes just 20 years.
And this brilliantly illustrates the mind-boggling amount of energy required to actually pull this off. To push those light sails to 20% the speed of light, we need an Earth-based laser array pumping out 100 gigawatts of power. That is roughly the total energy output of 100 large nuclear power plants, entirely focused on 2 sails just a few centimeters wide. It is a monumental engineering challenge, to say the least. The hurdles are definitely staggering. These delicate microprobes have to survive terrifying acceleration forces during launch. They have to endure the absolute cold and vacuum of deep space. And perhaps most dangerously, when you're traveling at a fraction of the speed of light, a collision with a single microscopic speck of dust literally turns into a catastrophic bomb-like impact. It seems nearly impossible, right? But remember, the entire history of space exploration is essentially a history of overcoming impossible odds to achieve absolute triumphs.
So I want to leave you with this thought. Just imagine the day those microprobes fly past Proxima Centauri and beam the very first up-close images of an alien world back to Earth. We aren't just going to see a faint dip in a graph anymore. We'll see a real world. Does it have oceans, clouds, continents? Seeing an alien planet up close is going to be a profound shock, a truly irreversible moment separating human history into a before and an after. Proxima Centauri is the ultimate paradox. It's so tantalizingly close, yet so incredibly difficult to reach. But for the very first time in human history, crossing that abyss is finally within our theoretical grasp. Thank you so much for joining me on this analysis of our closest cosmic neighbor.